So queue we have discussed. Next one is a circular queue. So why actually the circular queue and the double-ended queue introduced means what? In a normal queue, whenever you are deleting the element from the front, all the other elements need to move in forward direction, in a forward direction. So what is happening in that case? Just for switching the elements, taking so much time, for switching all the elements in that queue. So that's why along with the rear, the front also will move in the circular queue. So how to write that one? Suppose I'm writing the class, I'll explain the code along with that circular queue. Please observe a very, very important and the little complex thing also. Okay, I'm taking that here, my CQ, circular queue, I'm taking my circular queue. So parallelly, I'm explaining that how we are executing this one. Just a queue only, I'm just representing like this. This is the circular queue considered. Is the circular queue. Suppose with the size I am taking 8. Suppose that circular queue size I am taking around 8. Index also I am starting from one location. Suppose 0 is a 1 and is a 2 is a 3 is a 4 is a 5 6 7. Here first we ask them to read that size. Everything I am writing clearly. Import java.util.scanner, creating the variables, static variable, integer. I'm just writing CQ. That's all, one variable. Same as it is a queue, all operations we are performing using front and rear. But initially, front and rear not pointing to any values. And size, we are taking the variables like this. Initially, front is not pointing to any location and rear is also not pointing to any location. Got it? Now here I'm just taking the size. So what is the size? Sir, I just want to read. Okay, creating the object equal to new scanner class of system.in. We ask them enter size of the queue. Enter size of the queue. I'm taking into one variable sc dot next in top. Sir, separately for creation, I'm creating one method. Just create. Here you need to specify what is the size. I'm just creating that queue, my CQ, circular queue dot create, or directly you can call create passing that n value. So what will happen whenever you are calling queue is ready, just it will create. We are calling this method by passing the size what you have read. That will come and store into this variable. We are creating that CQ equal to new int of that n we are passing. That n we are passing. Got it? Okay. Now here, just that n we are adding to this size. Adding to this one. So whenever you are calling this method, it will execute and this n value will assign to this size variable. Size variable, it will go back and it is saying that queue is ready. After that, same queue operations, while true, just giving that system.out.println. One is for insert, system.out.println. Two is for delete, system.out.println. Three is for display, is nothing but traverse, system.out.println. Four is for exit. All the operations we are doing. All the operations we are doing, that is. So why extra variable n means what? How can you pass? Whenever you are writing the separate method, whenever you are passing the value n, then without using extra variable, we can't, because it is the common variable, it is for all. If you want to call this method, whenever you want to pass, that you have to write. If you don't want to write this extra variable, this xc.nextInt, you have to write this inside. That's all. Whenever you are calling, it will execute. Here, whenever we are using this, we ask system.out.print, enter your choice. The choice we are collecting using that sc.nextInt of. We are collecting that choice. So we know that common case, if choice is equal to 1, else if choice is equals to 2, else if choice is equals to 3, else if choice is equals to 4. That 4 is actually called, here it is, exit. Exit means what? Just end and break it. Else, just giving that invalid choice. Invalid choice, like this. Okay. Now here, whenever the choice is 1, for inserting the element, we ask them system.out.print, enter element to insert. Enter element to insert. That we are calling that insert method and passing that element. For that, we are writing the codes. All the methods I am writing. Static void insert. What is the element you want to insert? Static void delete. And here no need to pass. Next one, static void traverse. Static void traverse. Next one, static boolean is empty or and is full. One is full. Next one, static boolean is empty. That is all the methods which are required, just we have written once. Now we are writing the code for insert. Insert the element, just we are reading and we are calling, and delete we are calling from here, traverse we are calling from here. So now all we need to write codes only for the methods. Only for the methods. Look at this. First time, initially both are not pointing to any locations. Right? So whenever you are inserting, you have to use rare variable, because inserting from the rare. Whenever you are deleting from the front variable. Deleting from front, inserting from rare. You must use these two variables whenever you want to perform these two operations. So rare equal to -1, suppose. First insertion, rare value and front value become 0, 0. First insertion. When you want to insert first, rare and front make it 0 and insert the element using rare variable. But front also should pointing to this one now, because element is already there. So in this insert, first checking if it is full. We can't do anything. Directly Q is overflow or Q is full, we are writing. Q is a full. Else three situations are there. What are the situations? I'll explain. If, else if, else. After doing this, we are inserting. Same in a delete also. In delete also. Same story. But instead of full, we are just writing that empty. Delete. Instead of full, we are just writing this empty. Got it? Next, in traverse. In traverse, if it is empty, same. If it is empty, is it giving that is underflow? Q is underflow. While deleting also, Q is underflow. Else we need to display. That code we are writing later. Q elements are. And if it is a full, same one. If that condition satisfied, it will return true. Else it will return false. Is empty also. If the condition satisfied, it is true. Else return false. Here it is empty condition is easy, because initially, as soon as it is created, front and rear values become -1 and -1. Okay. So easily based on any condition, either front equal to -1 or rear equal to -1, you can say that it is empty. It is empty. Front equal to -1 or rear equal to -1, simply we are saying that it's empty. That is. So that is the first case. No, I just want to insert. First insertion. Remember, first insertion. When we are inserting the first element, both front and rear values should be 0, 0. First insertion. How can you say that it's a first insertion? When rear is equal to -1. Sir, why you are not taking front? Inserting from the rear, na? That's why. So make the front value and make the rear value both equal to 0. If. So when if block executes, you know that else if will not execute. So into that CQ of rear, because rear value 0, into that element inserted, just giving the message element inserted. This is first element insertion. First element. Sir, how many elements are there? Only one element is there. Last element deletion also very, very important. When the queue has only one element, last, okay, by the time front and rear both are same. Front and rear both are pointing to same location, either 0 or 1 or 2 or 3, anything, then that is the last element deletion. So in that deleted code, if it is not empty, first I'm showing that deleted, which one? CQ of front. See, deletion always front, but by the time front and rear both are equal, what is the meaning? It has only one last element. So front and rear will come to as usual position -1. See, in two situations I'll explain. Observe this. Suppose if I am deleting this one, so I'm giving the message is deleted 10 because front is pointing to that one. Now, as deleted that last element, front and rear equal to 0, 0. So now in place of 0, 0, again what values will come? -1, -1. As usual, will come to starting position only. Will come to starting position only. Now see, one more situation I'll show you, then you will understand. I'm removing this. I'm not deleting. So first I'm inserting 0, 0. First 10 inserted. Next I keep on inserting. So second element insertion. Front will not move now. Rear value become 1. 20 inserted. Again I want to insert. Rear value become 2. 30 inserted. So what is happening? In this rear, last else block, rear plus plus. First time only this if block execute. First time. Remaining cases, this will execute. So when this will execute, I'll tell. Rear plus plus. This one. Now see, sir, I want to delete. Okay. Delete the front. So front will move. Na? That is, sir, again I want to delete. Look at this. Delete this front. Front also will move. Na? Front also will move. Sir, now look at this. How many elements are there in the queue? Only one element is there. One element, 30. One element, 30 is there. By that time, look at this. Front and rear both are equal. So, when front and rear both are equal means it has only one last item. Then front and rear become -1, -1. So, if you remove this one, again it will come back to -1 and -1. Come back to -1 and -1. That is, when the last element in that situation, front and rear both values equal to -1. No, sir, I keep on inserting only. I keep on inserting only. So 1, okay. Next, rare 2, 20 inserted. Next one, rare 3, 30 inserted. Rare 4, 40 inserted. Rare 5, 50 inserted. Rare 6, 60 inserted. Rare 7, 70 inserted. It is full. Look at this. When front equal to 0 and rare equals to total size minus 1. When front equal to 0, full case. When front equal to 0 and rare equal to size minus 1. Size minus 1, it's a full. Sir, now it is a full. Consider. Now I want to delete, sir. Okay. Now deleting this 10. So front will move na? Front plus plus. Sir, where you have written the code? Front plus plus. When you delete, then else block is a front plus plus. Front plus plus. Sir, again I want to delete 20. Here it is that front value is a 2. Sir, again I want to delete 20 again. That front value is a 3. Sir, again I want to delete 30. Sorry. Front value 2. Front value 3. Delete a front value 4. So I'm deleting all these items. Look at this. All these items. Now Q is not full because see front is not 0. Rare equal to size minus 1, okay, but front is not 0. So Q is not full. Now I want to insert where rare value again becomes 0. Whenever there is a chance of insertion and rare value is moving to that size minus 1, rare value equal to 0. That's all. So again inserted. Now look at this, important, 80. Now again, suppose sir, again rare value become 1. Okay, 90. Sir, rare value become 2. Okay, insert 100. Sir, rare value become 3 because inserting that 110. Now again Q is full. Again Q is full. Look at this second condition. Now front is 0, rare is size minus 1, no condition false, but still Q is full. This is the second situation. Front C4, rare is a 3. Nothing but either front equal to rare plus 1 or rare equal to front minus 1. Because behind only it is there. This is actually front, this is actually rare. Behind the value only. Behind the value. So second option is for full, or this is for second reason. Front value equal to rare plus 1. Front value 4 equal to rare plus 1. 3 plus 1 is a 4. So two situations are there to make that Q is a full. To make Q is a full, two situations are there. Okay. Now see, sir, I keep on deleting. Sir, suppose 40 I am deleting. 40, its value become 5. Sir, next one is a 50 I am deleting. 50, that value becomes 6. Sir, 60 I am deleting. Then the value becomes 7. Sir, I want to delete 70. Next, the value will not become 8. It should become 0. Same in deletion also. In deletion also, whenever the friend reached total size minus 1 to the end, front also starts with the 0. That's all. That's all. Two things you need to write. The next one is, sir, how to display the details. Q elements are two situations are there. Sir, first situation, see, suppose, sir, I'm continuously inserting the details like this. See what is happening. Look at this. Suppose, sir, I keep on inserting the values like this. Rare value 2, 30 I'm inserting. Rare value 3, 40 I'm inserting. Rare value 4, 50 I'm inserting. So 0 to 4 we need to display. Situation, look at this. Front 0, rare 4. So front to rare. But if the front value is less than or equals to rare, for front to rare, starting from the front, that is 0, less than or equal to rare, all values printing happily. All values printing. System.out.println CQ of I. CQ of I. All values printing. Okay. But now, look at this. Sir, again I'm inserting 5, 60, 6, 70, 7 is 80. Now I'm deleting. Look at this. 10 deleted. 10 deleted. So front value become 1. 20 I'm deleting. Front value become 2. 30 deleted. Front value become 3. 40 deleted. 40 deleted. Front value become 4. 50 deleted. Front value become 5. Okay. Now, sir, I just want to display. I want to insert now. So rare value becomes 0. 90 inserted. Rare value become 1. 100 inserted. Rare value become 2. 110 inserted. Now, sir, I want to display. Now, see, look at this condition. Will you repeat the loop from 0 to rare or front to rare? No. Front 5, rare 2. Now, rare is behind, front is forward. So, two situations you need to display. Two situations. What is that? First one is a 5 to size. Nothing but front to size. For this one loop. Second one is a 0 to rare. For this one loop. Is actually like this. 5 is a front to size minus 1. 1 for loop is else case. One loop is starting from front to size minus 1. Nothing but up to end. Second one is starting from 0 to rare. Rare value 2. Look at this. 2. 0 to rare. One more for loop. 2 loops required. 2 loops. Starting from 0 to rare. 2 loops required. This one. This is the entire code, how to execute that circular queue. Just is empty. You have written, na? Okay, that's it. The code will run, execute the code, and check the output. Okay, I'll share the video. I'll share this code. Please write yourself. You keep on watching the video. If you are not getting, until you get, you keep on watch the video, no problem. But don't just type and check the output. You need to understand the concept, practice multiple times. Okay, you can leave.